Hello YouTube, we're back again, measuring some radioactive devices. Here I've recently picked up a brilliant red Fiestaware dish. It is about a 7.5-inch saucer, I maybe would call that. I don't know what their catalog actually calls it out as. Also, even though they call it red, it's actually much more of an orangish red color. For those of you that don't know, Fiestaware, they were one of the first people back in the 30s to really kind of break out of the classic era of dining, and they started making really bright color plates. They came in 5 or 6 different colors originally. And the thing that's really unique about them is to get some of that bright color, they actually used uranium oxide in the glaze, along with the fact that's from the 30s, it's lead also, so it's kind of the idea of how much toxic stuff can we stick on your dinner plate. But surprisingly, these are actually quite radioactive. My last video, I was actually getting ready to measure one of these with my old Geiger counter that I keep around, not for accurate measurements. It's not terrible, but more of just an antique. But today I brought a calibrated lidometer, just a gamma ray survey meter. So I unpacked this plate here. And let's take some measurements. So the first thing we'll notice is turning it on, even way back at the camera, you can already hear this thing starting to go. We're at 1x right now, and let's get a measurement here. Let's see how far away we are. From the center of the plate, if I come back, actually right here is approximately 2 feet. Let's see if we can get it to focus. Okay. Here, we'll give it some help. So here we're actually 2 feet away from the plate. And you can see we're already reading something along the lines of 0.05 millirems per hour on the 1x mode. So this is by far the most radioactive piece of material I've ever owned. The second most being the check source on the side of this Geiger counter here. And I mean, in comparison, right next to it, it's high, but nowhere near as we start to approach this plate over here. I mean, we pegged the meter this far out. So let's get a measurement of how radioactive it really is. If we set it to 100x, let's get you back in focus. If we set the meter to 100x here, and I'll take it off quiet mode again, we'll bring it right up to the plate. And you can see we are reading, I think we're sick of that buzz, so that's 100x, so that's about 50, no, sorry, that would be about 8.5 to 9 millirem per hour, which is quite a lot depending on the source you look at online. The government recommends, at least around the United States, somewhere around 100 millirem of dose to the general public. So that's via medical x-ray or living, near a pile of uranium, whatever you want to call it. So looking at this, I would get my yearly safe public exposure dose in 10 hours of holding this plate. Now that being said, that's exposure for the general public. Radiation workers, it's much higher if you're expected to get it in like a workplace environment through OSHA. But it's enough that I'm probably going to build some sort of a leaded box to keep this in. And I know some people have questioned before, like, okay, is this mostly alpha or beta particles that are pegging the meter? But here, if we just put a piece of aluminum foil, that should stop pretty much most alpha and some of the beta. I mean, you can see still on 100x, we're still pulling not quite as high, but it starts climbing up there, almost as high as the original measurement. And even adding something like a 1/16 of an inch of lead on it, here you can see the circular placement. We'll just put it right on top of the plate again. we have to go to 10x mode for this, but actually that's a little bit more than I expected. I expected there still be a significant amount of radiation there. I think this is about a 16th inch of lead. Let's put it on 1x and see what happens. So it's not like it's not knocking it out to anything, which I wouldn't expect, but my guess is if I covered a small box in even a 16th inch of lead, that would be more than adequate that I'd feel comfortable storing it anywhere in the house. I mean, as soon as I slip that away, it's a lot. So, Fiestaware, 1936, 1937. Around 1942, I believe they kind of discontinued the use of it because they needed uranium for some other things in 1942, as it turns out. Well, thank you guys for watching. If you ever come across this stuff, it's interesting. It's not worth a ton, probably because he wants to keep something this hot in their house, but, you know, it's a cool thing for a physics teacher or a college professor to show off in a physics lab. At least we're not eating off of them anymore. Thanks, guys. Bye.